Here's a nice little Grundig 2065 radio. It's got a tuning eye tube hiding in there and a central woofer as well as two electrostatic tweeters on the side. And it's an AM/FM shortwave radio like a lot of the radios from this era. The tuner here is a bit acting a little funny. It turns slow one direction and fast the other. And the volume knob is completely frozen over here. Almost completely frozen. It's very difficult to turn. So we got to loosen this up, and it's probably a spring that's loose here. That's why it turns fast one direction and slow another. Here's the electronic side of the Grundig radio. I've already taken the back cover off. It says 1500 volts here, so this must be for the electrostatic tweeters. It's got a number of tubes in here, which interestingly didn't match exactly with the tubes in the schematic that I have. They said an EL95 and this is an EL84, for example. And used an EM81 tuning eye tube, which is hiding up here somewhere. And this supposedly is an EM85 tuning eye tube, which is unfortunate because the EM85 is pretty rare and pretty expensive, about 3 or 4 times more expensive than the EM81. But we might be able to retrofit it if we need to. So this will be an interesting project with these electrostatic tweeters in here. We'll see if we can get that working again. Pretty sure that the caps need to be redone in the power supply. The owner, I think, has turned this on already, so I'm not too worried about trying to turn it on and test it and see what happens. So just to recap everything that we did on this radio. We we added a spring back in here where the tensioner is for the dial, so that we've got a stronger spring there so the indicator doesn't get stuck when it goes across. We replaced the capacitors inside with some new ones back here and took the original one out of the circuit, replaced the rectifier on the side here for the power supply, so that won't blow out now, and replaced the tuning eye tube with the original was the EM85, which is very rare and expensive, and this thing is totally shot. You can't even see the screen on it when it's on, hardly. And so I bought the EM85 to EM80/81 adapters here so that I could use the EM81 tube, which is remarkably cheaper, and it's absolutely beautiful in there. Still have to put this panel back on the left side here. We fixed the electrostatic tweeters on both sides, so those work now, and just oiled up everything in here that was mechanical, cleaned all the switches that I could reach. They were extremely difficult to reach, a lot of them. I also added this RCA jack on the back right next to the pickup here because we want to use an RCA input, and add a Bluetooth module here so that you can literally press a button here, connect it to your phone, and play your phone right through the radio. What I really was hoping I could do easily was add the power supply for that Bluetooth module right alongside and stuff it in here. And I had a cable made up and everything. The problem is this transformer wire goes into this box, and the only part that comes out is the switch wire that snakes around here and goes down a hole there. This box is virtually inaccessible unless you bend these tabs back and pull it all apart, and that is just something I wasn't willing to do. Who knows, a tab will probably break or something as you open it up. It just wasn't worth all the effort, so we're going to have the power supply external. The other possibility is I could tap into this 7-volt lamp, which apparently is on a isolated line, and rectify that and put a 5-volt supply on it and then cut this cable. But it's kind of like not really worth that much effort. It's probably better to just have the power supply for the Bluetooth adapter externally. And then since this is mono and this is stereo, we'll have to make a cable that goes from stereo to mono. But yeah, this thing, you can put it up top or whatever. You can put it in the back somewhere and connect your Grundig radio right up to your phone and play any tunes through there that you like. So overall, it's looking pretty good. After this, the next thing is run some furniture refinisher on the outside, hopefully spruce it up a bit, and finish cleaning up the front a little, and we should be good to go. to say this is not one of the easiest radios to take apart that I've ever opened up. It turns out that I did have to take off this perforated bottom board. Initially I thought I wouldn't have to, but then I found this sneaky little copper wire here is attached to one screw on that bottom board, and that bottom board's not metallized, so, well, maybe it is, and maybe it's some kind of conductive paint, I don't know, but it's kind of odd to have a ground wire going to a piece of cardboard. So that surprised me. And here is the tuning eye tube, which is buried way up in the top there. The speaker's actually quite generous. It looks like about a 6x9 size. And then these flaps here are to scoop the bass waves out the side, and probably the mid-range as well. And additionally, we have these strange electrostatic tweeters here on both sides, here and here, which send high frequency signals out either side. I'm really curious to get this thing fired up now, because I'd like to know what it sounds like with all that stuff working. Looks pretty cool. But we got our work cut out for us here. Those open variable capacitors, probably full of dust. We're gonna have to clean that out. This light bulb doesn't work, I'm told. Yeah, here's the tensioner for the AM/FM dial. And there's another wire here that looks extremely thin. I don't know if that's original or not. It's very old, I can tell you that. And there is a wire going to it, which is even... Oh wait, that's not a wire. That's the... that is a wire, but it's the indicator for the AM/FM. And down here I see an original power supply cap that's going to need to be replaced. A couple other caps here are probably foil paper, so they might be alright. Well, alright. Oh, and here is the germanium semiconductor that people have warned us that it should be replaced. These things are very fragile, and if it's not working, if it is working now, it may not be in short order, so much better to replace this with a bridge rectifier, so I'm going to go ahead and do that. I can see two sections here from a power supply cap, and I'm going to work on getting that bypassed and taken out of the circuit. Alright, well, it looks like a neat project. Here we go. I should point out that this volume control that is seized up has a tap on it so that it acts more like a loudness control than a volume control. And that's going to be basically irreplaceable, more or less. So hopefully we can bring that back to life with some lubrication, because it's just totally seized up right now. Additionally, there's a pickup input here, which I find amusing, because this might be a really good place to insert a Bluetooth module. Therefore, when you turn on this device, this radio, you could actually hook it up to Bluetooth and run it through your smartphone, which might be preferable for some people. It's only about $20 to add a Bluetooth system to something like this, where it's already got an input that could be suitable. So far we've validated the voltages on this capacitor here, which doesn't mean that it's good, but it means that, well, this isn't shorted out. This is the bridge rectifier, and this should be replaced because it is original, and these are pretty sensitive. So I can replace it with any bridge rectifier capable of handling the voltages needed. Unfortunately, I don't seem to have one on hand, so I could make one with 1000-volt diodes instead. It would be nice to buy a bridge rectifier, because it'll easily fit in a smaller area than that. Next in here, I checked the voltage on this electrolytic capacitor down here, the silver one at the bottom. That's the voltage to the output tube, the EL84. That should be about 7 or 8 volts, and it's reading about 6. So I don't like that capacitor being electrolytic down there, so I'm going to replace that. And of course, that seems to be the first thing they installed, so it's going to be super hard to get it out and replaced. And there's another electrolytic that needs to be replaced here. I think that's the only 3 in here, which is good. It's pretty easy. So we'll bypass this. I think I'll keep it in the circuit, probably add 20 microfarads to each section just to give it some more life. And then we'll replace those two. I also bought some converters. This is an EM85 tube. This is a really rare one that's like over $100. and this thing is really weak. You can barely see the line on it, this tuning eye indicator. So I bought a little converter to allow me to use an EM81 or an EM80 in its place, and just plug it into the socket and walk away. So I'm hoping that will work for us, because I can get an EM81 for $8. This one is the super rare one. So right now I have the pickup button turned on, and this wire is just a dead short to short out the pickups for minimum noise coming in. All the fixes that I've done so far, but I still get this weird kind of noise once in a while in here. It's like a crackle or something. And I haven't been able to figure out where that's coming from. The closest thing so far is maybe the EL84. If you wiggle it, you tend to hear some noise. I don't seem to get that with the other tubes. Probably need to clean the sockets and check, but it's there anyway, so. A mysterious crackle. It could be a power supply, could be the sound of this rectifier going bad. And maybe it's the old capacitor that I just bypassed instead of taking it out of the circuit. I don't know, it seems like it's going to take some experimentation to figure out what's causing that weird crackle sound. Or maybe we'll just leave it in there as part of the vintage vibe. Yeah, I want to see if I can get rid of it. It's going to take a while to track it down though. Here's a thought. Let's try turning the volume down or up. See if it gets louder or quieter. Okay, I think I've got the volume maxed. Of course I still hear it at max. So let's try turning it to min. I think I've got that all the way on min now. Yep. And I still hear it. Okay, so that means that it is one of the last two tubes here, or the power supply. We put a scope on the power supply to check. I'm not sure if that will help or not, because every time that crackles, it's pulling current from that power supply. So you're going to see it on the power supply, whether the power supply is the cause of the noise or not the cause of the noise. So that might not really get us anywhere. We'll try a couple of things here. Alright, so I discovered that the original power supply capacitor down there is bad, and I'm hearing that crackling noise. I just couldn't figure out where it was coming from. I replaced the bridge rectifier to no avail, and then I already had the capacitors there, so I actually pulled one off, and lo and behold, the sound is on, and there's no crackle noise now. There was a little bit of hum. And so what I did was I removed my 22 microfarad capacitors that were brown, and I swapped them out with 47 microfarad capacitors, which is close to the original spec of 50 microfarads. So I've got two 47 caps, and I boosted it with an extra 22 here just to help cut down the 60 hertz hum. The extra capacitance is no problem for this bridge rectifier. It can handle 200 amps peak and 800 volts repetitive reverse voltage. So man, beautiful. There is no crackle noise at all. I just turned the volume all the way max, and it's almost silent. It's really amazing. I'm going to disconnect my short on the pickup here. Should probably turn the volume down a bit first. So I'm disconnecting the ground. Okay, so you hear 60 hertz hum. Okay, you can turn this up all the way. Of course, this is something you shouldn't be doing, but just to show the incredible silence right now. It's really remarkable. Wow, I'm impressed. So that was worth hunting down. It was not the bridge rectifier, which I'm glad for, but people say that you should replace these old bridge rectifiers because they will eventually blow out. And I can't seem to find where I put it. Oh, here it is. This is an old germanium rectifier. It will easily blow out someday, but that was not the problem. The problem was the power supply capacitor, the original one. So always take your power supply caps out of the circuit, the old ones, because they do have some serious leakage issues and they can arc over and blow up if there's if they ever get worse. But yeah, you want lower noise in your system or crackle or something, get rid of those old power supply caps. So this radio came with an EM85 tube, which unfortunately is extremely rare. If you can find them, it might be $100 to replace it. It's a tuning eye tube used to indicate if you're locked into the radio station or not. Well, thankfully I was able to find these converters on eBay that convert from an EM85 tube at the base into an EM81 or an EM80 on the other side. And I can pick up an EM80 for $8. And this is actually an EM81 right here. Lo and behold, the converter works. And you can turn the radio up a little bit here. And I can change the radio station. Let's see, it's a little bit too hard to see that now. It's so bright compared to the old one, you can't even see it. So as I tune this, you can see that the eye opens and closes depending on whether I am on a radio station or not. And so basically a direct replacement just because of the use of that converter there. So wow, simple fix for a $100 problem. If you could find an EM85 replacement. This one was so weak that even in the dark you can barely see the screen on it. And so there we go for what, $8 plus maybe $5 for this base. We've got it working. Now for a look at these strange electrostatic tweeters. I really don't know how these work. Clearly this wire on the top goes to this front perforated panel, but this one seems to be completely unconnected. I can't see a wire anywhere leading off of it to anything. And so I'm kind of mystified what's going on here. There is a shiny piece of plastic here, as if maybe there was a foam block or something, perhaps that conducted the electricity and then that thing eventually disintegrated, perhaps? I don't know. The other clue is the plastic here is clearly warped and warped inward. So if this plate was very close to the perforated one and it warped together inward, then you'd have a short in the middle somewhere. So that's something else to investigate here. I'm going to see if we can figure out what's going on with these electrostatic tweeters.